Hey guys, welcome to question MM246 of the Maths Methods Fortify study guide. So this question says, over the course of 5 months, Theon Greyjoy's masculinity is measured. Theon has some cool things going for him when t equals 0 and his masculinity grows. His masculinity plummets as he's going through some rough times, and it finally bottoms out when he has some one-on-one time with Ramsay Snow. Awesome. So this is the point where it bottoms out. Theon's masculinity is modeled by the function m from 0 to 5, where m of t equals negative 3t log e of t on 5, where m is Theon's concentration of masculinity measured in chest hairs per square inch, and t is time in months after he becomes a man. The graph of m is shown below. Awesome. So, part A asks us, what is the maximum concentration of chest hairs Theon has during this 5-month period, corrected to decimal places? Awesome. So, first things first is whenever we say the word maximum, we know that we're going to be looking for this point here, which is our turning point. So at a turning point or a stationary point, our derivative is going to equal 0. Okay, so that means that m dash of t is going to equal 0. Now we can use our CAS in this question, so I would advise doing that. If you want to look at the worked solutions, there's basically a walkthrough of how to do the product rule here, which is what we would need to do. But I'm going to say, according to CAS, m dash of t is equal to negative 3 minus 3 log e of t on 5. Awesome. So from here, we know that the gradient is going to have to equal 0, which means 0 is equal to negative 3, take 3 log e of t on 5. Rearranging all this, we get negative 1 is equal to log e of t on 5, which means that e to the negative 1 equals t on 5, so t is equal to 1.84. So at this point here, t equals 1.84. And that's our first mark, okay? But we're not looking for that. We're looking for our maximum concentration of chest hairs. So m of 1.84 will give us our chest hairs, which means that we have negative 3 times 1.84 times log e of 1.84 over 5, which gives us 5.52 chest hairs per square inch. Awesome. This is our second mark and final mark for part A. Just make sure that you include your units, which in this case is our chest hairs per square inch. Guys, let's move on to part BI. Part BI asks us to find corrected to decimal places, the value of t when the concentration of Theon's chest hairs first reaches 4 hairs per square inch. Awesome. So, we know that our masculinity is given by negative 3t log e of t on 5. And we know that the concentration that we're looking for is 4 hairs per square inch. So we let our m equal 4, and then we need to simply solve for t here. So t on 5. From here we can solve in CAS. So solve in CAS. This gives us t equals 0.66 and t equals 3.36. Now, the question asks us for the value when it first reaches 4 hairs per square inch. So t equals 0.66 is less than this, so that's going to be our first time it reaches it. So therefore, t equals 0.66. That's our first and only mark for part B, which was just 1 mark. And that's it. So we just let our m equal 4 and then we solve for t based on that. So, let's move on to part BII, which is also a 1 mark question. So part BII asks for the length of time that Theon's masculinity is above 4 chest hairs per square inch. So pretty straightforward with this one. We know that it first reaches 4 per square inch at 0.66. So let's say here. We know that it goes back down at 3.36, which is somewhere here. So the time between here is where he's above that, right? So in between here, he's above 4 chest hairs per square inch, which means that to find the difference between them, we get t above is equal to 3.36 minus 0.66. Now we need to make sure that we use our full decimals, okay? So this is actually, so in the calculator, this would actually be 3.364 minus 0.657, right? So we rounded these initially, but what this is actually going to give us is 2.71 months. That's our first and only mark for part B, II. And that's it. So we just need to work out the difference between the first time he reaches it and when he comes back down and reaches it again. So 2.71 months is our final answer. Let's move on to part C. Part C is a 2-mark question. And says, what is the value of the average rate of change of Theon's masculinity over the interval 1-4? Express your answer in chest hairs per square inch per month, correct to 2 decimal places. Awesome. So as soon as we see the words average rate of change, we should think gradient between 2 points. So is equal to our gradient, which is y2 minus y1 over x2 minus x1, okay? So we know that the interval is 1-4, which means we're going to need to find our corresponding y values at those points, okay? So m of 1 is equal to -3 log e of 1 on 5, and m of 4 is equal to -12 log e of 4 on 5. Now finding these two answers is our first mark, and then our second mark is going to come from our answer, which we plug our values into this to get. So second y value is -12 log e of 4 on 5, minus our second y value, which is -3 log e of 1 on 5. Try not to get confused with these negatives, because that'll skew your answer. Our second x value is 4, our first y value is 1. So this actually ends up giving us, if we just put this straight into the calculator, we get -0.72 chest hairs per square inch per month. Awesome. I don't know if you guys, that's all right, you understand. Per square inch per month is that end part. Awesome. So that's our final answer. So rate of change is equal to -0.72. That's our second and final mark for MM246C. If you have any questions, let me know, but let's move on to part D. Part D is a 2-mark question. And it says, at time TA, the instantaneous rate of change of Theon's masculinity is equal to the average rate of change over the interval 1-4. Find the value of TA correct to 2 decimal places. All right, awesome. So we know that we know that the average rate of change over the interval 1-4 is -0.72. Now in your CAS, if you put that in, you would have actually got as an exact answer log e of 125 over 256. So we're going to use this for now so that we don't have any rounding errors at the end. So we know that this is our average rate of change, and we know that that's equal to our instantaneous rate of change at TA, right? So our instantaneous rate of change is our gradient, which is m dash of t, okay? We know that m dash of t is equal to -3 take 3 log e of t on 5, because we found that before. And so we know that that is equal to log e of 125 on 256. Awesome. Now, this is essentially our first mark. So that pretty much, like, recognizing that is your first mark. And then we can go through a whole bunch of working to get to our t value. If you want to see the full working, check out the work solution. But we know that if we solve this, we get t is equal to 2.34 correct to 2 decimal places, which means that TA is equal to 2.34. That's our second and final mark for part D. Hit me up if you have any questions. If you want to know how we get from here to here, there is some use of the calculator, but you can cancel out the logs and that sort of thing as well. So check out the work solutions or post up a comment below. But other than that, let's move on to part E. So part E now starts talking about Rob. So this is a 3-mark question. Rob Stark's masculinity was also being measured once he became a man. The concentration of his masculinity can be modeled by the function. Now, if you can see x's in your function here, just treat the x's as t's, right? Because that was a typo on our behalf, but we've fixed that up now. So r of t is equal to rt log e of kt, where t is between 0 and 5. Awesome. So if Rob's maximum concentration of masculinity is 8.46 chest hairs per square inch at t equals 2 months, find the values of r and k correct to 2 decimal places. Awesome. So we know that our function passes through the point 2, 8.46, right? Because it's 8.46 test hairs at t equals 2. Cool. So we know that it passes through that point. And we also know that that's the maximum concentration, okay? Which means that r dash of t is equal to 0 at this point, which means that r dash of 2 is equal to 0. Okay, so we're going to use these two things to figure out our values for r and k by using simultaneous equations. Awesome. So whenever we've got whenever we've got two different variables, you're going to have to use simultaneous equations. So let's start off with this one. We can simply sub in 8.46 is equal to r times 2 times log e of k times 2. And then from there we can get 8.46 equals 2r log e of 2k. And this is our first simultaneous equation, okay? So this is the first one we're going to use. And our second one comes from our r dash of 2 equals 0, right? So according to our CAS, r dash of t is equal to r log e of kt plus r. Awesome. And then from here we know that this is equal to 0 when t equals 2. So 0 equals r log e of, when t equals 2, we have 2k in here, plus r. And this is going to be our second simultaneous equation that we use, and this is actually where we get our first mark. So from here, we know that there are two simultaneous equations, so what we're going to do is plug those into our CAS into solve systems of equations. You can, I think it's menu 371 or 372 that you can use that with, and that is going to give us r is equal to, well, we can do that, but we do need to make sure that we show working. So let's actually go through that whole working. Alrighty, so from number 2, so from this one here, we can say that we can take that r to this side. So I'm only doing this because it's a 3-mark question. If it was a 2-mark question, I'd probably just sub those straight in. But we actually, on reflection, we actually do need to show the full working for this. Equals 2k. We can divide both sides by r and we get -1 equals log e of 2k, which means that e to the power of -1 equals 2k. So k is equal to 1 over 2e. We need to get our equations correct to 2 decimal places, which means that k is equal to 0.18. It's our second mark. Awesome. And then using our first equation, which we had, we know that 8.46 is equal to 2r log e of 2k. So 2 times 1 over 2e, which means that we have 2r log e of 1 on e, which gives us -2r equals 8.46. So r is equal to -4.23. That gives us our third mark. So we found our value of k, we found our value of r corrected 2 decimal places, which means that that's it for MM246. If you have any questions, please hit me up in the comments below. But otherwise, thanks for watching, and I'll see you in the next video.